Hi friends, today we are going to discuss one additional data type added in C# 9.0, that is native size integer. We can have this native size integer type with .NET Core 7.0 inbuilt because it supports C# 9.0 onwards. So native size integer is having two types. One is unint. Unint can have negative, positive value including 0, and second one is unsigned integer. It can have value greater than equal to 0. So max length for nu int is greater than nint because it can have only positive value, same like normal int or long data type. So it is value type and we can consider it as an extension of integer, which will solve your overflow exception for integer, and it will have increased capacity for your integer variable in case of storing data. So as I mentioned, it will solve your overflow exception. So first we will see what is meant by overflow. So while doing arithmetic operation, if you set value to integer more than its capacity, so it is considered as overflow. This is for other type also, but we are considering integer here. Okay. So now we will see practically how overflow occurs and how runtime will behave in case of overflow occurs. Okay. So I have created one variable and assigned max value it can according to its capacity. And to produce overflow, I am adding +1 to max capacity, and this is this. So it is +1 than integer capacity. So overflow should occur here. Now let's see how runtime behave in this case. Okay, it doesn't throw exception here, but let's see value of my integer. It is giving some wrong value. Okay, some negative value, so it is garbage value you can say, and it is not useful for our programming. Either it will break at some other place, next place, or it will give you wrong output. So this is not correct behavior and we should throw exception here. But by default runtime CLR is not throwing that exception because this is unchecked code, means arithmetic exception are not thrown. If you want to throw exception, we can add check here. Means check means we have to check for arithmetic exception, and if any exception occur, CLR will throw that exception. So let's see, we will execute our code once again, and what happened? Yeah, it's exception, and we can see it is overflow exception. So correct behavior. So we are able to produce overflow for integer. Okay, now as I mentioned, this can be solved with n integer. So let's see how we can solve this. So I just change it to change this integer to n int. Okay, now again I am setting this to maximum integer value, and I am then adding +1 more than integer capacity, and let's see. Exception doesn't occur. Okay, sorry, I think I missed something. Exception doesn't occur, and yeah, its value is correct. 21474836. 214746. So we can see value is perfectly fine. So it doesn't occur for this overflow exception does not occur. We get proper output. Okay, so this way overflow exception gets solved because n int is having more capacity than integer. It is again having star clause also. We will discuss that. Okay, and if you go for auto, that one more observation we can see. Okay, now if you try to assign max length value to integer, so that is fine for compiler because it can accept that value. But if you assign value more than its capacity, auto resolver itself saying that instead of int, convert it to uint because uint is having more capacity. Perfect. Yeah, sure. So let's remove this. I will redo all on code. So this way we were able to solve our overflow exception. Okay. Now one more capacity. So what is max length of an integer? Definitely it's greater than integer because it solves our problem, but it depends. It depends on your runtime in which you are running your code. It may be web or mobile or console application, at which place or at which runtime or what runtime you are doing this execution. According to that, max length of native integer change varies. So this is my 64-bit machine and I'm running on 64-bit. That's why its capacity. Let's check. I will check capacity of n long here, and we can see my integers. I have added one screenshot here which will tell you capacity. So this will tell you native integers capacity. Integer max length. Username max value. Yeah, that's fine. So I'm running this program on 64-bit, so overflow exception not occurring, and now we have to check what is capacity of n int for this program execution. Yeah, you can see value is something 92223, and this is same like my long. Okay, so now it is behaving as a long, as we mentioned here. In case of 64-bit environment, it is behaving as a long, so it is max length same as long. Okay, perfect. Now what happen if it is 32-bit? Okay, I will change this x86. First I will check whether it's x86 proper or not. Yeah, perfect. So now I am running my program on 32-bit. Okay, and let's see first, will it throw exception? It should throw exception. Yeah, it throw exception. Why? Because now n int is behaving like integer because we are running this on 32-bit program. So for time being, I will comment this code and I will run it again to see max value. Okay, max value is 2147 something, and you can check it is same like integer. Okay, now we can prove this point that when your runtime is 32-bit, n int will behave as an integer, and if it is 64-bit, it will behave as a long. Okay, and I have added this screenshot also. So these are capacity of int, uint, long int, ulong. So n int is same like integer in 32-bit and long in case of 44 or 64-bit, and nu int is same like uint in 32-bit and same like ulong in 64-bit. Okay, I hope you understand. If you like this video, please subscribe and like our channel, and if you have any point or suggestion, please feel free to add it in comments. Thank you guys.